In this video, we're going to do another balancing example where we're going to do a combustion reaction, and we're going to have a chance to practice the four-step process that I like to teach, where step one says just balance the carbons. Step two says just balance the hydrogens. Step three says balance the oxygens, and I'll write fraction okay, and I'll explain what that means in a moment. And then step four basically says if you used a fraction in step three, go ahead and multiply everything by 2. Now, when you're balancing reactions, you're not supposed to use fractions. At least you're not supposed to have fractions in your final answer. And even that is a lie, because if you take a full general chemistry course at the college level or AP chemistry, fractions actually do show up when we're doing enthalpy of formation reactions. But I don't know if that's part of your course or not. But this is going to be the four-step process, and basically if we have to use a fraction in step three, don't worry, we'll get rid of the fraction so that we're following the standard rules saying no fractions allowed. Anyway, we've got this hydrocarbon, C8H13OH, and it says it's reacting with oxygen in the air. So oxygen is one of these 7 diatomics, so oxygen in the air means O2 gas. And then our products are carbon dioxide gas and water vapor. So anytime you're just combusting a regular hydrocarbon, your products are pretty much always CO2 and H2O. Now, step one, just focus on the carbons. So what that means, I see 8 carbons on the left side, and I need to think, what number should I put in front of CO2 so that I have 8 carbons on both sides? Well, we'd want to put an 8 right here, so now just the carbons are balanced. And next up, hydrogens. So I see we've got 14 hydrogens over here from that hydrocarbon, and inside one water molecule, there's 2 hydrogens, and 14 divided by 2 is 7. So if I put a 7 right here in front of the H2O, that would give me 14 hydrogen atoms on both sides. Okay, so the next, balance the oxygens, where you could put, any number there. It doesn't have to be a whole number. If you need to put a fraction to kind of force them to balance, that's okay. And then you have to keep in mind, you've already got 1 oxygen from that hydrocarbon, so that's going to complicate things. Now, just counting up what we have on the right side. From the carbon dioxide, I have 8 times 2, so I have 16 from that. And then 7 times 1, so I've got 7, so that 16 plus 7, what is that, 23? So I've got 23 oxygens on my right side. So that means I want to have 23 oxygens on the other side. Now, I got to put a number in front of O2. That's the idea. But I also have one more over here. So a way to figure it out, I want 23. I already have 1 from the hydrocarbon, so that gives me 22. And then each oxygen molecule has 2, so if I do 22 divided by 2, that gives me 11. So if I put an 11 right here, let's see if that works out. So now let's count up the number of oxygen on the left side and see if we did that properly. So I've got 11 times 2, that's 22, plus the 1 more over here. So that gives me 23. And again, here I had 8 times 2 is 16, 7. So 16 plus 7 is 23. All right, so we're good. It's balanced. So we didn't need to do step 4 in this one. But if we had to put a fraction here like 11 halves or 13 halves or something like that, then you would just multiply everything by 2. And I'll have another video that demonstrates that.